We're going to go ahead and use those limit laws that we saw on the previous page to practice computing some limits. And what I will tell you is that this is going to be really tedious. It's going to be painful, and you are not going to want to write out all the details, but you need to write out all the details for these limit law problems. And what I will give you kind of this as a word of hope is that we will not have to do this for very long. We will have one class period and where we have to do all these tedious details, and then we'll find easier ways to deal with this. So hold on for today, write out all the details, and then we'll deal with this later. Okay, so in this problem, we've got three functions, f, g, and h. We know something about their limits up here. And now we're going to use limit laws to compute some other things. We notice that x is approaching -1 in each of these. So all of these examples we have to have x approaching -1. Otherwise, we're not going to know what to do. So for this first one, we see that we have 3f of x plus h of x, and we have that limit law that says we can break addition inside of a limit into two separate limits. So we can make this the limit as x approaches -1, 3f of x, plus the limit as x approaches -1 of h of x. Okay, you have to write that limit out each time. I will take points off if you are not writing those limits out. So with the limits, this equality might not hold if we're not working with limits. So you have to include the limits. Okay, so that was one of our limit laws. Let's see, that was limit law number 1, told us we could break addition up. Now we notice that this 3 is a constant on the inside. So limit law number 4 told us we can pull constants out. So I'm going to pull this constant out. Once again, tedious, write all the limits out. It's not fun, but we have to do it. Otherwise, it's not mathematically correct. So I pull the 3 out of that first piece. We still have that limit. Actually, let's go ahead. The second piece here will make our life a little easier. We know that that is equal to 3. So I can just write a 3 out here. Okay, now this piece here is equal to 2. So I can have 3 times 2 plus 3. So that's 6 plus 3, which gives me 9 out here. Okay, so the limit laws allowed us to compute that limit using all of these properties. Okay, try some of these other ones and see what you can do with these other ones. And I'm going to keep recording, but you should try them on your own first. So this next one, I have division. Limit law number 5 says I can break division apart so that this is the limit as x approaches -1, f of x plus 1 over limit as x approaches -1 of g of x. Okay, that denominator will just be -1 from this limit up here. That numerator still has addition in it, so I have to break that apart. Sorry, my email keeps dinging here. So if I break that addition up using limit law number 1, I have the limit as x approaches -1 of f of x plus the limit as x approaches -1 of 1. Okay, so this piece here is 2. And then this piece here, that's where we have a constant, just a constant all by itself inside of a limit. That's where we use limit law number 6. That tells us I'm just going to get the 1 out. So I get 2 plus 1. So that gives me 3 over -1, which is -3. Okay, so we're going to keep going. So once again, we can divide the division up. So I have limit as x approaches -1 of f of x. Okay, I'm going to be lazy. We'll skip one step here in this one. So I'm going to divide here, but I have addition. So I'm going to go ahead and use limit law number 1 on that addition as well. So I have a limit as x approaches -1 of g of x plus limit as x approaches -1 of 1. Okay, my numerator is 2 from up here. The g of x approaches -1 plus 1. We get 2 over 0. Getting 0 in the denominator is a problem. If you look at limit law number 5, it tells us that we can only use these limit laws if the denominator does not give me 0. So this limit law doesn't tell us anything. We can't do this. So we really have no idea what happens in this problem. Getting 2 over 0 does not mean that this does not exist. It doesn't mean it's equal to 0. We don't know. And this is going to be what we spend the next week or two working on, is figuring out what happens when we get 0 in the denominator. The limit laws don't apply. So what do we do? Okay, so we'll just leave that one be. We'll come back to it eventually. So this next one here, we have multiplication. Limit law number 3 tells me I can break this apart into f of x and a limit of g of x. and just multiply those together. F of x gave me 2, g of x gave me -1, so I get -2 out. Okay, one last one for this one. I have a square root. Limit law number 9 tells me I can move that limit inside of the square root. And then I have addition, so I apply limit law number 1 to break this apart. F of x plus, sorry, you know, this is so tedious. It's a pain to write all of this out. And I know that you don't want to, I don't want to either, but we really need to do this for all of this to be mathematically correct. Okay. So f of x approached 2. So this part's 2. This part's going to be 2 by limit law number 6 because the limit of a constant is just the constant. And so that's the square root of 4, which just gives me 2 out. Okay. These next 3 or 4 examples, I'm actually going to get rid of this one. I didn't want to include that one. So these next 3 examples are all going to be examples where we don't have those previous, we don't have that information we had above. We don't have an f of x and g of x, but we can still follow the same process. So we have addition and subtraction here. So we use limit laws 1 and 2 to break this apart into a 14 minus a limit as x approaches -2 of 6t plus a limit as t approaches -2 of t cubed. Okay, the 14 is just a constant, so limit law number 6 tells us that we get 14 out. This one here, I have a 6 inside. Limit law number 4 tells me I can pull the 6 out, and I'm going to go ahead and just be lazy and go ahead and pull it out here. Okay, and then this one, the last one has a t cubed. Limit law number 8 tells me I can do the limit and then I can cube that. Okay, so now we just have to worry what happens to these 2 pieces. If I have just a single t, this is property number 7, where I can just plug that -2 in. So I get -2 out for both of those limits. So I'm going to have -6 times -2 plus -2 cubed. Okay, and when I do all of that, I get 18 out. Okay. This one here, we bring the limit inside of the square root. That was our limit law number 9. You don't have to memorize what numbers these correspond to. I'm just telling them as I go through these today so that you get practice with that. And we'll go ahead and break this apart as well. Of 6, okay, and then this piece here I can pull the square out. Okay, so I'm skipping a lot of steps, but that's okay. You can kind of get down to this as long as you understand which limit laws I'm using. That last limit law I used was number 8. Okay, so now as z approaches 0 of just a z, we're going to get 0 out by property number 7. So we're going to have 0 squared. By property number 6, since this is a constant, we just get that constant out. So we're left with a square root of 6, which does not simplify nicely. Okay, this last one, I didn't mean to include that note down here. So let's try this one before we read what that note says. So we can divide this apart with the division and then break each of those pieces apart. So I'm going to have the limit as x approaches -5 of x plus the limit as x approaches -5 of 7. In the denominator, I have a limit as x approaches -5 of x squared. And we remember we can rewrite that as a limit squared using property 8. I can pull that 3 out because it's a constant, and a limit as x approaches -5 of x minus a limit as x approaches -5 of 10. And I'm okay if you kind of skip those few steps, like combine steps into one and just jump straight to here. This is okay. So now we plug the -5 in for x, we get -5 out. The 7 is a constant, so we get a 7 out. We plug the -5 in for x, so we get x or -5 squared, which is 25. We plug in the -5, so we get 3 times -5, which is -15, and then the 10 is a constant, so we get -10. Now we notice we get 2 over 0 again. That's very sad. Remember, our limit laws told us that they don't actually apply if we get 0 in the denominator, so we don't know what to do here. So trying to solve problems like this one in particular, that's our long-term goal. How do we deal with this? How can we simplify this so we can make this work? And it's going to behave. It's not going to be too bad. We just have to figure out what will happen here. Okay.